Question number 1. The first structure is a question. A student followed the following steps during the experiment of finding relative density of a metal. He wants to find the relative density. Step A. A sphere made of metal was suspended from spring balance and the balance reading was taken. So what is the first thing here? This is a Newton balance, right? This is the hook of the balance. This is the point where the balance is connected to a support, right? The metal ball is hung by the balance. So what is the reading of the balance at this time? W1. Right? Reading of the balance is equal to the weight of the metal ball, mg. Right? So reading is given as W1. So from these two, right, I can use arrows and say, therefore, W1 equals mg. First equation. Draw this figure here. Structure is a This is the first thing that the student has done. After that, what does the student do there? Step B, the sphere was completely immersed in water and then the balance reading was taken. So what will happen when the ball is completely immersed in water? So let's say this is the water vessel, this is the ball. Water is up to this point. So when the object is immersed in water, weight of the object acting downward mg and water gives an upthrust R Newton. Right? This is a string. From this string, the ball is connected to the hook of the balance. Right? So now the reading of the balance is equal to actually tension. Here also this tension T1. This is T1. So actually T1 is equal to W1. T1 equals to mg, therefore W1 equals mg. Here the tension, let me take T2. Tension, let me take T2. Now reading is equal to W2 and T2 is equal to W2. This is what you want to get from this. Draw the second figure also. First object is kept in air, second object is completely immersed in water, then there will be an upthrust of capital R Newton. Please write below the figure. Please write below this figure. Please write for the equilibrium. For the equilibrium, forces acting upward should be equal to the summation of the forces acting downward. T2 and R acting up. Summation of the forces acting upward, T2 and R should be equal to the force acting downward. T2 plus R equal mg, but T2 is equal to W. So therefore W2 plus R equals mg. So this is the second equation. I obtained 1 and 2 equations. Before I answer the structured equations, first I draw the figures. I obtain these relationships. After that, I'm going to answer the questions. Write them all here. Write them all. Roman number 1. If the volume of the sphere is V and density of the metal is D, write down an expression for W1. Roman number 1. What is density here? Density of the, is it a ball? Density of the metal equals mass over volume. Density of the metal is given as volume is V, density of the metal is D. Density of the metal is D, mass of the ball is M, volume is V. If I take V to this side, I'll obtain D times V equals M. Complete. But we know that W1 is equal to mg. But we know that W1 equals mg. And W1 equals m is equal to dv. So this is dv times simply dv. That's it. So this is what they ask in Roman number 1. Write it out and Write an expression for W1. W1 equals dVt. That's it. Roman number 2. Write an expression for the upthrust on the sphere in the step B in terms of density of water. What is upthrust here? What is upthrust? Upthrust equals V rho G. So I have marked the upthrust as R, volume of the sphere V, and that is the here in V means volume of the displaced liquid. As the sphere is completely immersed in the liquid, volume of the displaced liquid is equal to the volume of the sphere. Density of water, let me take it as rho W times G. Let me mark this as the third equation. This is the answer for the third question. V rho W G. V rho G. What I get when I made a Roman number 3. Derive an expression derive an expression for relative density of metal using W1 and W2. Look at both here. Look at both. I'm going to use this equation. For the equilibrium of the ball, upward force should be equal to the downward force. It is asked us to write down an expression for the relative density. Upward force T2 plus R equals mg. From that I have obtained W. T2 is equal to W plus R equals mg. So this is a structure in the same paper. So I'll write at once. Mg equals W2 plus R equals mg. W2 plus R. What is R here? Upthrust. V rho WG Okay, dear. What can I do now? Please write these two steps. Look at board. W2 plus V rho WG equals Mg is W1, right? W2 plus V rho, sorry, let me subject, let me do something like this. Let me take W1 to the other side. V rho WG equals W1 minus W2. Am I right there? Now I'll divide all the terms by density of the metal D. V rho WG divided by D equals W1 minus W2 divided by G. Now we have done like this. Clear? Divided by D. Now I get the reciprocal. If I get the reciprocal, what will I obtain? Please write up this thing. Reciprocal लेकर तो बात है. If you get the reciprocal, you get D divided by V rho WG equals D over W1 minus W2. This what is D over rho W? Density of the metal divided by density of wood. Relative density. Relative density. D over rho W divided by V times G equals D over W1 minus W. Take it to the other side. Take it to the other side and you get relative density equals V G D divided by W1 minus W2. For the V, substitute from this. D times V equal M. From this you can subject. Or from this, D W1 equals dVg. So therefore, what should be VD? Please write it. Please write it. You see that? dVg equal W1. Already we have obtained dVg. dVg. So this is actually dVg. D into D into D, D into D into G equals W minus like this. dVg is W1. So this is W1 divided by W1 minus W. That's it. Roman number 4. Step 1 important point that has to be considered during step B. What is step B? The sphere was completely immersed in water and the balance bearing. Step 1 important point that has to be considered during the step period. The sphere should be completely immersed. We should check whether the sphere is completely immersed or not. For the Roman number 4, please write. It must be checked whether the sphere is completely immersed. It must be checked whether the sphere is completely immersed. It must be checked whether the sphere is completely immersed. That is the most important. Step 1 important point. Check whether the sphere is completely immersed. Roman number 5. If several spheres are made of that material are given, the sphere having the highest mass which can be measured with the given balance should be used for this experiment. Give the 2 reasons for that. Why should we use the sphere having the highest mass? When the sphere has larger mass, the mass measurement will be larger. When the mass measurement is larger, percentage error of the mass measurement will be reduced. Because percentage error is least count divided by measurement. When the measurement is larger, error will be reduced. Right? Roman number 5. There are 2 reasons. Roman number 5, first reason. When the mass measurement is larger, percentage error of the measurement is reduced. When the mass measurement is larger, the percentage error of the measurement is reduced. The percentage error of the measurement is reduced. When the mass measurement is larger, the percentage error of the measurement is reduced. What is number 2 deal? If mass is larger, volume is also larger, then the upthrust will also be larger. What is it? When upthrust is larger, there will be a considerable difference in W1 and W2 readings. Got it? Please write. When the mass is larger, volume will also be larger. When the mass is larger, the volume will also be larger. Volume will also be larger. When the mass is larger, volume will also be larger. Full stop. Then upthrust becomes larger. V-roti. Then the upthrust becomes larger. Therefore, same point. Therefore, there will be a considerable difference between W1 and W2. There will be a considerable difference between W1 and W2. Mass is large, volume is also large, then the upthrust will also be large. That's it. Roman number 7. The volume of the sphere is 200 cubic centimeter. and the density of water is 1000 kilogram per cubic meter. The values obtained for W1 and W2 are 8.01 Newton and 5.99 respectively. Find the upthrust. Find the upthrust on the sphere when it is fully immersed in water. Use Archimedes principle. What is upthrust here? Roman number 7, Roman number 6, simple A. Roman number 6, simple A. Upthrust is V rho WG. Volume is given as 200 cubic centimeter. How do we convert cubic centimeter into cubic meter here? 100, 10 to the power minus 6. This is 1000. G is 10. And now let's erase cut the zeros here. 1, 2, 3, 4, 5, 6. Can you see? 1, 2, 3, 4, 5, 6. Minus 6 and these 6 zeros cancelled out. Upthrust is 2 Newton. Very simple questions. Very simple question. Simple B. If is there a difference between the values W1, W2 and obtained value A? If there's a difference between the reason for that, what is W1 minus 2? W1 minus W2? What is the difference? Normally, thrust is equal to W1 minus W2. I think we have proved it. We have proved somewhere here. Look at what in W2 plus R equal mg. In a W2 plus R, mg is W1. In a R equals W1 plus W2 come this side as minus W2. We can write this as a not later. So it means W1 minus W2 is should be equal to our thrust. Shall we check whether this is correct? Shall we check? We can write this note later. We can write this note later, right? Roman simple B. W1 minus W2. They have given W1 as 8.01. W2 is given as 5.99. You have to take one to this side, another one to this side. So this will be 9, 10 plus 1, 11. 11 minus 9 is 2, 9 minus 9 is 0. 7 minus 5 is 2.02 Newton. So this is a negligible small difference here. Upthrust 2 Newton, W1 minus W2 2.02 Newton. That difference can be neglected. The reason for this kind of things may be human errors. Maybe we have connected the, we have used the string, wound on the string to hang the ball. That's the reason. You write this dear first. You write this dear and write this note also. Write the answer. What's the answer here? Answer is there is a very small difference between R and W1 minus W2. Reason. Errors in the measurements. There may be errors in the measurements. So what is the answer for the question? That's a very small difference between R and W1 minus W2. R is 2 Newton. W1 minus W2 is 2.02. 0.02 is the error. That's a small difference. What is the reason for that? There may be errors in the measurements. No, don't write like that. It's a joke. The final question is find the density of the metal relative to water using W1 and W2. Density of the metal relative to water means relative density. Density of the metal relative to water means relative density. We have an expression for relative density. What is it? Check. What is relative density? Relative density equals W1 minus W1 divided by W1 minus W2. Relative density, that's the final question, is W1 divided by W1 minus W2. W1 is 8.01. W1 minus W2 is 2.0. Divide this and give me the answer. Relative density is just a numerical value, it's just a number without units. Divide it here. If you divide, you will get 3.96. If you have written an answer closer to this, it's enough. 3.96. Even if you write 4, that's okay. So we have successfully discussed first structure equation. Write them all.